Okay, so I'm back once more. This lecture, we're going to be talking, as promised, about two-dimensional arrays. So it seems that I'm incapable of making a lecture video that's less than about 40 minutes. So every time I say that this shouldn't take that long to go over, that it's just a limited scope lecture, it always takes forever. So I'm not going to say that this time. Maybe that will help. But this is a limited scope lecture. We only want to talk about 2D arrays, so let's talk for just a second about what that means. Okay, specifically, what you have usually been. Oh goodness. There we go. What you have usually been talking about when dealing with arrays is a 1D, a one-dimensional array. And we've always sort of conceptualized them in the same way, just as a single row, okay, which so we don't have to even worry about that. And then there are individual units of memory allocated to values of whatever type this array is. So if this is an integer array, then we store integers in here. If it's a character array, we store characters. If it's a string array, we store a whole string of things in each location in the array. Okay? Those are all one-dimensional arrays. So they have only one index. Okay? And if we want to get this value, then we will look at the name of that array and we will look in index 6. Okay? That's pretty straightforward. That's pretty much what we've been doing all along. One index equals one dimension. Okay? But in general, we can have any number of dimensions. It's very unusual indeed to talk about a structure that has more than 3 dimensions. We live in a 3-dimensional space. Our brains tend to think 3-dimensionally. If we start talking about 4-dimensional structures, there's nothing that keeps the computer from understanding what that means, but those are rare to kind of use because it is difficult for our brains to keep up with it. So the higher order dimensions we usually don't deal with. In fact, in our class, the only upper level dimension that we're going to deal with is the next level up is 2D, or the second dimension. So not only is there an index, okay, which we'll come to call the columns, but now we also have row values, okay, and those are also indexed from 0 to n-1, where n is the number of rows that we have. So what I've just done, and I'm bad enough at this when I'm drawing actually by hand, and my troubles are compounded that much more when I'm using a mouse to draw this. Okay, but this is the structure, the conceptualized structure that represents a 2D array. Okay, so this is a we would call it a 5, okay, by 8 array. It has 5 rows and 8 columns. Okay, 1, 2, 3, 4, 5. Notice there is a second index here that goes from 0 to the number of rows minus 1 to go along with the first index that we're used to, 0 to the number of columns minus 1. Okay? If there had always only been one row, then we could ignore the fact, right? It's just a normal one-dimensional array. But now with multiple rows and multiple columns, we need we need to take to get to an individual cell in this table or matrix or two-dimensional array. Those all mean the same things. We would do the name of the value, and then we would have 2 pairs of square brackets, right? So let's say we want this value. That is name at position 2, 4. Okay? This is 0, 0. 0, 0. This is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 1, 0, 1, 1, 1, 2. All right, and each one of these gets a unique, so each of these cells gets a unique pair value of indexes, and that's how we're able to access each individual cell. Okay. All right, so let's look at some code and see how we can actually do this. Here is, let me clear this. Here's a simple example that I've gone ahead and coded up. You'll notice that I have. Let's focus at the main function to begin. We'll come back and look at the print matrix function. But this is the way you define a two-dimensional array. Just like with a single-dimensional array, you list its data type first. So this is a two-dimensional array that is going to store integers. Its name is table, and it has 2 rows and 3 columns. Okay. Then I'm going to create value equals 11. Actually, this is from a previous thing. We can ignore that. So for int r equals 0, r is less than 2, r plus plus. So r stands for rows. So the index for the rows is 0 through 2. Okay, so let's draw this, because this is what our array looks like right now. Our array called table, our two-dimensional array. Okay, 0, 1, 0, 1, 2. That's what our array looks like, right? And so I want to iterate first using this row, and then using this row, and then finishing. So this will work while r is 0 up to but not including 2, one at a time. Okay? All right, so then for each, because this is a nested for loop right here, for each row, we're going to look at each column from 0 up to and not including 3, right? So we're going to look at each row and each column one at a time. So the first value, table RC, table 0, 0, will be this one. Then we'll iterate the inner for loop, and it'll be table 0, 1, and that'll be this one. And then table 0, 2, and that'll be this one. And then that'll be the end of the inner for loop, and we'll dive back into the upper for loop, and now r's value will be 1. So it'll be, when we dive into the inner for loop, table 1, 0, table 1, 1, table 1, 2. Okay? And each time we're putting values in there. Okay? And then we're going to call print matrix. Okay? So now let's take a minute to examine what print matrix does. It has a void return type. Its name is print matrix. It accepts a two-dimensional array. And we can tell that it's a two-dimensional array because it has square brackets, and there's 2 of them. Okay? Now, when you pass a multi-dimensional array, you have to list all except for this first value. Okay? So in this case, we have to list exactly how many columns there are, even if we don't have to list exactly how many rows there are. Then we're also going to pass in the size of the array by using 2 integers in order to do that. Now, also, just like for single-dimensional arrays, and we won't see this working in this code example, but you need to be aware of this. Just like with one-dimensional arrays, two-dimensional arrays are always passed by reference. Okay? So even though there's no ampersand there, it's always passed by reference. So changes that get made to this array in the function are actually being made to the original array as well. There is only one array. There are just multiple names for that array. Okay? So here we go. Now we give it a name. It's going to be called ARR in the function. Then we have int r, int c. So when we pass in table, ARR is going to be a new name for table, which is our two-dimensional array. And R is going to take on a value of 2, and C is going to take on a value of 3. So those are both pass by value, standard pass by value. Right, so for 0 up to less than the size of the number of rows, so X is going to be 0 and then 1. 4 nested inside of that, so for each row, we're now going to do this for each column in that row. And effectively what we're going to do is we're going to print out that position at that column, at that row and that column. And then we're going to put a space in between each value in each row. And after each row, before we dive back into the outer for loop, we're going to go to the next line. So the first row is going to be on the first line, all the values with spaces in between them. The second row is going to be on the second line, all the values with spaces in between them. Yeah, so that's basically it. So I want to give you a second. I'm gonna pause for just a second, or have you. Yeah, I was afraid that was gonna happen. Here, okay. So I'm gonna pause for just a second to give you a chance to try and trace this code. Okay. In other words, before you type it in, and run it for yourselves. Take a little sheet of paper out and try and determine what do you think is going to happen with this code. Okay, hopefully you paused the video there and worked it out. Luckily for us, I've already coded this up and we can easily see it. Oh, that's not what we want. Okay. So let's compile this example. Okay, and then we'll run it. And there's the output of that code. Because at each level, at each step, we added the combination of the R value and the C value, or the R index and the C index. So 0 plus 0 is 1. 0 plus 1 is 1. 0 plus 2 is 2. 1 plus 0 is 1. 1 plus 1 is 2. 1 plus 2 is 3. Okay? Try and make sure that you understand that. Code this up, copy this down, code it up, play around with it to make sure that you understand what's going on. All right, there's one more thing I want to look at. So here's a live in-class example that I'm going to do right here. So let's write a main program that creates an integer two-dimensional array. Okay, and it's going to be a 4x3 array. So we're going to put in our normal stuff here, int main. Okay. It's going to be an integer array. It's called array. Let's call it matrix. And it's going to be 4 by 3. So, 4 rows by 3 columns each. Okay. And it says to initialize the first row to 4s, the second row to 3s, the third row to 2s, and the fourth row to 1s using the declaration statement. Okay, so how do we do that? Well, just like you have comma-separated initialization lists for single-dimensional arrays, you have very similar comma-separated initialization lists for multi-dimensional arrays. Now you could actually put all the values in just a single comma-separated list, and then the first row would be filled in, and then the second, and then the third. But it's often a little bit more clear to have a comma-separated list of comma-separated lists to keep track of what's going where. So there's 4 rows, so we need 4 initializer lists. And then there's 3 values in each row. So the first row is going to be all 4s. Okay. Second row is going to be all 3s. Okay. The third row is going to be all 2s. and the fourth row is going to be all ones. Okay, so that's our initializer list to do exactly what was required of us in that in the second part of the assignment up top. Okay, declare and define the print matrix, and then make a call to that function to test your work. Okay, so here's the call to print matrix. Okay, and I know I'm going to need to pass in the matrix and its number of rows and its number of columns, and then that's the end of the main function. So we need to define print matrix. All right, so, and it's very similar to the last one we saw. Void print matrix. It accepts an integer array, two-dimensional array, and remember we have to tell it all except for the first dimension, size of the first dimension. So it's 3. Okay, and then an integer for the number of rows, an integer for the number of columns, aka the size of the array, the two-dimensional array. Okay, print matrix. Okay, now finally down here we need to give it this array a name. Let's call it mat. All right, it is a like that int. All right, so r int column. Okay. All right, so r will be 4, column will be 3 when we call it in our example. So let's do outside for loop. So for each row, x is less than r x plus plus. Okay. And then inside of that, for each column, y is less than c, y plus plus. Okay. We are going to print out the value in the matrix, the two-dimensional array, at position x and y. Then we're going to print out a space. We're not going to go to the next line just yet. We don't want to go to the next line until we're finished with all the values in that row. Then we'll print out the next line, and then we'll go to the dive into for the next row. Okay. All right. So I think that does it. I just made this up right here, so that was live coding. So as with all live coding examples, there are likely to be errors. Let's try and see if we can root them out if they exist. So this was in class example 2. Yes. So why did I say J++? Because I can't type. All right, let's try that. Okay. So no compile time errors. Doesn't mean there aren't runtime errors. Let's see if this works. There you go. All 4s in the first row, all 3s in the second row, all 2s in the third row, all 1s in the fourth row. Okay. All right. I hope that's pretty straightforward. There is a assignment that goes along with this lecture, and if you look at Canvas, all right. So I don't know. I think I even have it open. Let's see. If you look at Canvas, you will see that, let's go down here to the modules. I don't think I've made it visible yet, but I will. Okay, you have, obviously, you've got programming assignment number 6, just down here, April 9th, April 14th. Then you've got assignment 17, April 10th. That was the sorting assignment. And then the 2D array assignment is assignment 18, and that's due April 12th. It's not visible yet, but I will make it visible here shortly. Okay. All right. I hope that's pretty straightforward. I hope that if you have questions, you'll let me know. That will be the last new material to be covered by the exam that we'll take next week. I'm working on the details about that still. Stay tuned. Within the next couple of days, I'll have the full rundown on how we're going to do that. Okay. Excuse me. All right. Hope everything's well. Hope you're safe and sound and healthy. And I'll be talking to you soon.